Hi everyone, Namaskara, Namaste. Welcome to Micro Math Show. BreathMath is presenting Micro Mathematics Show. What is Micro Mathematics? Patterns, graphs, shortcuts and Vedic mathematics. To pursue your dream, you need mathematics. And under mathematics, there is one important chapter to understand calculus. That chapter is functions, and in that function, absolute value function is a micro concept, and today in this episode let us explore modulus function. So what is modulus function or absolute value function? Let us try to understand this first. If we write y is equal to modulus of x, what does that mean? Let's say x value is plus 1, then y becomes modulus of 1, which is 1. If x is minus 1, y becomes plus 1. X value plus 2 and y is plus 2, and x value is something like minus 10 and y becomes positive 10. That is the meaning of modulus function. Now, how mathematicians define modulus function? So, by observing this, mathematicians define modulus function or absolute value function in this way. Plus x for all x greater than 0, minus x for all x less than 0, and 0 for x equal to 0. This is the definition of modulus or absolute value function. Many of those mathematics students, they ask why we are using negative x. You said it's the y value is always positive, and how we are getting negative x here? So the basic understanding goes like this. For all positive value, when x is positive, y is also positive, isn't it? So y has to be plus x. X equal to 1, y is 1. X equal to 3, y is 3. X equal to 5, y is 5. But when x is negative, let's say minus 2, minus into minus 2 will give you plus 2. Y has to be positive, isn't it? To make y positive, here I should write negative x. If I write positive x here, x is negative, you say, isn't it? So minus 2, if y is minus 2, then y becomes negative. That should not happen. So minus of minus 2 is going to give you positive value for y. That is the reason we always write minus x for all x less than 0. So this is the definition of modulus x. Now, how do you draw the graph of this absolute value function? So you draw x-axis, you draw y-axis, 1, 2, 3, minus 1, minus 2, minus 3. Numbers goes like this, 1, 2, 3. So when x is equal to 1, y is also 1. When x is minus 1, y is plus 1. When x is plus 2, y is plus 2. When x is minus 2, minus of minus 2, plus 2. So if you join these points, you get a beautiful curve like this, which is absolute value function. Using coordinate geometry, you can draw the graph. Now, how these things, how these micro concepts are going to help you in entrance examinations to pursue your dream? Here is a beautiful question. F of x equal to mod x, then f is many one, f is everywhere continuous but not differentiable, f is an even function, and all of the above options. Right now, you know how to draw the graph of absolute value function. It looks like this. Now, if you have a pen, you take out your pen, hold the pen in front of the graph. You realize that this horizontal line cuts the graph exactly at 2 points. If it cuts the graph, the curve, at more than 1 point, the function is minimum. So option A says this function is minimum. It is true. And what about the second option? F is everywhere continuous. Yes, it is. It is continuous everywhere, but not differentiable at x equal to 0. Is that true? Yes. If you find any sharp edge in the graph, you can conclude that at that point function is not differentiable. Option B is also true. What about option C? It's an even function. What do you mean by even function? If the graph, the curve is symmetrical about y-axis, you can say it is even function. Meaning f of minus x, you get modulus of minus x, you get back the original function which is f of x. F of minus x equal to f of x clearly show that this function is an even function. So all of the above 3 options are correct. Option D is the correct answer. Now, second question. The function is modulus of sin x. It's a composite function. We have 2 functions. One is sine and the other one is absolute value function. But modulus of sin x, how do you draw the graph? You draw x-axis, y-axis, and you draw sine function. You know the sine function goes like this from 0, and here you have pi, 2 pi, 3 pi, it goes on like this, minus pi, isn't it? When you have modulus sine, like this, which contains some other function, then you need to take the mirror image about x-axis. Meaning, all negative part that is below x-axis, those part will go and sit above x-axis. That is the meaning. So, if you know this graphical shortcut, easily you draw modulus sin x graph, right? So, this particular graph shows sharp edges at different points. 0, pi, 2 pi, 3 pi, meaning at x is equal to n pi, this curve is showing you sharp edges. At all these points, x equal to n pi, the function is not differentiable. So, option B says f is everywhere continuous but not differentiable at x is equal to n pi. Correct answer. Did you enjoy? So all that you need to do is learn some graphical shortcuts. That's it. Which will save your time, and within 10 to 15 seconds you can answer such questions, isn't it? Next one. Here you have f of x equal to modulus of cos x. One more composite function. Inside the modulus absolute value function, cosine x is sitting. How do you draw the graph of this particular function? For this, you have to draw cos x graph. Cos x starts from +1 and it descends. So this one is y equal to cos x graph, and you have to take the mirror image about x-axis, meaning you cut all this part below x-axis and take the mirror image about x-axis. Here you get sharp edges. What does it mean? At this point, function is not differentiable. Wherever you find sharp edges, at that point function is not differentiable. Reason is, at that point you can draw 2 different tangents. What is dy by dx? Dy by dx is the slope of the tangent. Wherever you find sharp edges, at that point you get left hand derivative, right hand derivative. 2 different things. They're not equal. That is the reason you say whenever you find sharp edge, at that point the function is not differentiable. So here f is everywhere continuous but not differentiable at x equal to 2n plus 1 pi by 2. Why? Cosine x drops down and it comes to 0 at x equal to pi by 2. Cos 90 is 0. Cos 3 pi by 2 is 0. So multiples of odd numbers. Multiples of pi by 2 odd numbers. 1, 3, 5, 7. So how do you write odd numbers? Odd numbers are 2n plus 1. 2n is an even number. 2n plus 1 is an odd number. So odd number into pi by 2 will give you the points where the function is not differentiable. So it's all about modulus of cosx function. Next, we'll see if the modulus is sitting only for x, f of x equal to sine modulus of x. In such cases, what kind of graph you draw? You have to take mirror image about y-axis this time. You stand in front of the mirror and look at your face and do some makeup. Now imagine the mirror is standing exactly on y-axis. So if y-axis acts as the mirror and sin x is looking at the mirror, in that case the image looks like this. Yes? So the sharp edge is created exactly at x equal to 0. That's it. You got the answer. So f is everywhere differentiable? No. At one point it is not differentiable, that is 0. I think option D says it is everywhere continuous but not differentiable at x equal to 0. Hope you guys are enjoying. Alright, next question. F of x equal to cosine of modulus function. Now how do you draw? The same principle you need to follow. You have to stand in front of the mirror, that is y-axis, and you look at your image. So right now the cos x is doing makeup. So the cos x graph goes like this. It starts from +1 and drops down. Now you take the mirror image about y-axis, but you realize that there is no sharp edge. For cos of mod x, there is no sharp edge in the graph. In fact, it's exactly same as the original function cosine x. Did you see that magic? There is no sharp edge at all. Smooth edge at x equal to 0. So the conclusion is it is everywhere differentiable. It is everywhere continuous. So which option is correct? Look for correct option. F is everywhere differentiable. Option A is the correct answer. Next one. Function is e power modulus of x. According to this, we have to take the mirror image about y-axis. So draw x and y-axis. E power x, it's a well-known graph. E power x passes through this point, which is 0, 1. In fact, all exponential functions would pass through the point 0, 1. That is the basics. And now you should take the mirror image about y-axis and you cut the part of the curve sitting behind y-axis, right? And draw the mirror image. It looks like this, and at x equal to 0, function is not differentiable. Till here, what you learned? Anything sitting inside the absolute value function, you equate that term to 0. You realize that at that point, function is not differentiable. Exceptional case was this. In this case, if you simply take the term sitting inside the absolute value function and equate it to 0, at x equal to 0, function is differentiable. To know that fact, you have to draw the curve. So the best approach is to draw the curve, graphically represent that function. That is going to give you the right answer. So the micro maths show is showing you the beauty of mathematics, and I'm sure you guys enjoyed. To answer this question, the question says the derivative of function at x equal to -1. They're not looking for derivative at x equal to 0. Derivative at x equal to -1. Somewhere here. So derivative exists. Derivative exists, and you have to differentiate e power minus x. For x less than 0, absolute value function is minus x. That's what we learned in the beginning. So e power minus x, you differentiate this term, and dy by dx, or derivative of this function, is e power minus x into -1. Apply the chain rule. So minus e power minus x is going to give you the final answer. Option C is the correct answer. Next question, let's see what it's going to talk about. E power minus modulus of x. The range of this function. So whenever you have negative sign like this, what you need to do is you have to flip the graph. Y equal to mod x looks like this. This is absolute value function. What about y is equal to minus modulus of x? This one shows y equal to minus mod x. So moral of the story is it's upside down. Yes, so whenever you get negative sign behind absolute value function in the graph, you have to do this operation, this transformation. So this is the moral of the story. Now let us draw the graph of e power minus modulus of x. X-axis, y-axis. E power minus x goes like this. This is e power minus x, passes through the point 0, 1. But you have to cut the graph behind y-axis. What we have observed till now is this. Y-axis acts as a mirror, and to draw e power minus modulus of x, whenever modulus is sitting around x, you have to take the mirror image about y-axis. So in that case, the graph looks like this. So if this is the graph of y equal to e power minus mod x, then easily you can say the range of the function is this. Starting from 0, it goes up to +1, y value. So the range of the function is 0 to 1. Option D is the correct answer. This will give you the range of e power minus absolute value function. Till here, you have come across so many composite functions which are directly connected to absolute value functions. So the micro mathematics is showing you the minute details so that you can handle any such questions in any of the competitive examinations. So here is log mod x. How do you draw this graph? Till now you have observed that whenever the modulus sign sits next to x, or x is sitting inside modulus of x, in all such cases you need to take the mirror image about y-axis. So draw log x curve. Log x passes through 1, 0. This is y equal to log x function. But you take the mirror image about y-axis. There is nothing to cut. No part of this curve is sitting behind y-axis. So I don't have to cut anything. Take the mirror image, it goes like this, but it would never cross y-axis. Range of the function is all real numbers from -infinity to plus infinity, the domain of the function is r minus 0. So the domain is r minus 0, whereas the range is minus infinity to plus infinity. They're asking range of the function. Y value tells you the range of the function and x value gives you domain of the function. Domain is this, range is option D. Is that clear? By looking at the graph, you should tell the domain, range of the function, whether it is differentiable, whether it is continuous or not, even function, odd function. All these details can be obtained from the graph of the function. That's the beauty of micro maths. Show the function f of x equal to modulus of log mod x. How do you draw this graph? You have twice, the modulus sign is appearing twice. So the graph of log x goes like this, passing through the point 1, 0. Now you take the mirror image about y-axis. This is log mod x. But if you put modulus to log mod x, you have to take the mirror image about x-axis also. So if you do that, the curve, the final curve looks like this. How is it? You have to cut the portion below x-axis and take the mirror image, and you do get sharp edges at +1 and also at -1. This one is the point, maybe -1, 0. So by reading the graph, by looking at the graph, you can conclude that the function is discontinuous at x equal to 0, and it is not differentiable at -1, +1, and of course at 0. The question says it is not differentiable at 3 points. Option C is the correct answer. Reason? It is discontinuous at x equal to 0, and you can see sharp edges at +1 and -1. Next one. Final question, f of x equal to modulus of mod x minus 1. It is not differentiable at. You repeat the same concept, taking mirror image about y-axis and x-axis. First you draw mod x minus 1. Modulus function. Mod x looks like this. -1. When you have negative sign, -1, outside modulus function, you have to shift the graph, transform the graph 1 unit below x-axis. If +1 is there, you need to shift 1 unit in the upward direction. Now you are shifting the graph 1 unit in the downward direction. That shows mod x minus 1, which is sitting inside this modulus. Fine. So mod x minus 1 is this. You have shifted the original graph to this point, y equal to -1 point. This is 0, -1. All right, but the final version of the graph should look like this. Is it correct? You see, modulus of mod x minus 1, I have to take the mirror image about x-axis. So delete this portion of the graph and take the mirror image. Then you find sharp edge at x equal to 0, at x equal to -1, and x equal to +1. How do you know these are +1 and -1? You need to equate the term inside the modulus to 0, then mod x is equal to 1, x equal to ±1. Those are the points where the function is not differentiable. Alright? So meaning this function is not differentiable at 3 different points, ±1 and also at 0. So this one is a micro mathematics show. To pursue your dream, you need mathematics. And in mathematics, you should master particular chapter. Maybe differential calculus or integral calculus, trigonometry, permutation combination. And in that, you have to master particular concept. So that's all about Micro Maths show. To attend the complete Micro Maths show, for each chapter, you click the link given in the description box. Every week, there will be one Micro Mathematics show conducted by BreathMath, and most important, that is, you get a completely free course which is Exam Stress Relief Methods. I repeat, Exam Stress Relief Method course is completely free. It is a bonus along with Micro Maths show. So what are you waiting for? Go to the description box, click the link in the description box, and that will add you to our WhatsApp community, BreathMath. I welcome you guys to BreathMath Micro Mathematics show. Thank you. Namaste.